Did you know it takes over 22 hours for a signal from Earth to reach Voyager 1? Launched back in 1977, the Voyager probes have traveled billions of kilometers away from the Sun, even crossing into interstellar space. These aging explorers continue to provide us with remarkable and rare insights into the cosmos. But not long ago, Voyager 1 transmitted some extraordinary data back to Earth, data that immediately caught the attention of scientists. One thing was clear: something powerful had occurred out there in the vastness of space. However, as researchers dug deeper, they realized this wasn't just any cosmic event, it was the beginning of an enormous mystery. Stay with us until the end to uncover what Voyager 1 detected in the deep reaches of space, and the astronomical enigma it unleashed. Distances in the universe are truly mind-boggling. Just consider that the average gap between Earth and the Sun is around 150 million kilometers, a figure that's already hard to wrap our heads around. But even that pales in comparison to the staggering 25 billion kilometers that Voyager 1 has now put between itself and our planet. To date, only one other human-made object has come close, Voyager 2, which trails behind at roughly 20 billion kilometers from the Sun. What makes their journeys even more extraordinary is the fact that neither spacecraft was originally built to reach such extremes. Their mission was simply to study the outer planets, a realm that was still shrouded in mystery back then, and they were only expected to operate for about 10 years. Yet, decades later, both Voyager probes continue to defy expectations, showing that 1970s engineering was more than capable of venturing into the most distant corners of space. Of course, it's no surprise that this once cutting-edge technology is now severely outdated. But that only adds to the legacy of these trailblazing spacecraft. If you're watching this video on your phone, you're holding a device with millions of times more storage capacity than the Voyager spacecraft. Their mission data is still stored on magnetic tapes with just 536 megabits of capacity. In comparison, today's mobile communication speeds are nearly 40,000 times faster than those of these aging pioneers. Yet, despite their outdated technology, Voyager 1 and Voyager 2 have accomplished something no smartphone, or any other space probe, has ever done. They've journeyed into interstellar space. Launched on August 20th and September 5th, 1977, with Voyager 2 actually launching before Voyager 1, the probes initially explored the 4 outer planets of our solar system. After capturing the first, and in some cases only, images of Jupiter, Saturn, Uranus, and Neptune, along with gathering an enormous amount of scientific data, NASA made a historic decision: to extend the mission and send both Voyagers beyond the edges of our solar system. Here's what the Voyager probes discovered in interstellar space. On August 25, 2012, a historic milestone was reached. Voyager 1 became the first spacecraft to enter the farthest reaches of the solar system. Scientists were particularly focused on understanding how the Sun interacts with particles and magnetic fields beyond the heliosphere. To clarify, the heliosphere is a vast bubble of space dominated by the Sun's magnetic field and solar wind. It acts as a natural shield, protecting our solar system from much of the cosmic radiation in interstellar space. After Voyager 1 crossed and studied this boundary, its twin, Voyager 2, followed on November 5, 2018. This gave researchers an exciting opportunity to compare the earlier findings with new data gathered from a different point of entry. Surprisingly, the comparison revealed a remarkable consistency, confirming that the nature of our cosmic surroundings is quite different from previous assumptions. Scientists had long believed that the heliosphere was asymmetrical and extended far beyond the Sun in one direction. However, data from the Voyager mission suggested otherwise, that the heliosphere is actually spherical and symmetrical. But that wasn't the only surprising discovery. Significant differences in plasma behavior were also observed. Before Voyager 1 crossed the heliopause, the outermost boundary of the heliosphere, it recorded a sudden drop in plasma flow. As it moved into interstellar space, it encountered intense plasma turbulence. Based on this, researchers assumed that the heliopause was a thick and unstable transition zone. So it came as a shock when Voyager 2, following a different path, encountered a boundary that appeared thin and unusually stable. What could explain these striking differences? According to scientists, the answer lies in the varying influence of the Sun. Voyager 1 crossed the heliopause during a period of low solar activity. This timing allowed interstellar magnetic fields and cosmic radiation to push deeper into the outer regions of the heliosphere. In contrast, by the time Voyager 2 reached this boundary, the Sun was in a more active phase. This heightened solar activity likely reinforced the heliopause, stabilizing it against external forces. Voyager 2 also confirmed the presence of a vast magnetic barrier on our side of the heliopause, acting as an extra shield against cosmic rays. This magnetic structure is believed to be the strongest field within the heliosphere, and it's part of an incredibly dynamic system. According to scientists, this shield is shaped by magnetic currents that move toward the heliopause, eventually weakening and dispersing to the sides. When the Sun's magnetic field flips polarity with the next solar cycle, the entire process restarts, only with reversed magnetic orientation. Moreover, the Voyager probes revealed that the interstellar magnetic field is 2 to 3 times stronger than previously estimated. As a result, interstellar particles exert up to 10 times more pressure on the heliopause than scientists had expected. Despite these groundbreaking insights, our understanding of the solar system's boundary remains far from complete. What we do know is that the heliopause and the interstellar medium form a dynamic and intricate system, one that has only been directly observed in 2 isolated regions. The vast frontier of interstellar space still holds many mysteries waiting to be unraveled. Given this situation, future follow-up missions will be crucial, but they'll have to be carried out by a new research probe. The reality is, we must accept that the Voyager program is approaching its final chapter. Sadly, sudden technical failures and loss of contact have become increasingly common for Voyager. Just a few weeks ago, NASA had to activate a set of thrusters on Voyager 1 that had been dormant for decades in a last-ditch effort to keep the historic probe operational. To prolong the mission as much as possible, NASA has placed both Voyager probes on a strict power-saving regimen. Instruments that aren't absolutely essential are being shut down one by one. Today, only 3 of the original 10 scientific instruments are still functioning. Thankfully, one of them, the plasma sensor on Voyager 1, was still active in the fall of 2022. Thanks to it, this aging spacecraft managed to deliver a stunning discovery that left even seasoned astronomers stunned, the most powerful gamma-ray burst ever recorded. On October 9, 2022, Voyager 1 was speeding through space at its usual velocity of about 61,000 kilometers per hour when its instruments detected an unusually large surge of high-energy radiation. This marked the beginning of a cosmic event that would reach Earth 19 hours later. It soon became clear that this gamma-ray burst was unlike anything ever seen before. Gamma-ray bursts are already among the brightest and most energetic explosions in the universe, capable of releasing in mere seconds as much energy as the Sun emits over its entire lifetime. Yet this particular event, designated GRB 221009A, was something else entirely. It was measured to be 70 times more powerful than any previous gamma-ray burst on record. The radiation was so intense that it overwhelmed gamma-ray detectors worldwide and even triggered noticeable disturbances in Earth's ionosphere, despite the explosion occurring 2 billion light-years away. Its unprecedented brightness quickly earned it the nickname BOAT, short for brightest of all time. Scientists noted that such an extreme event is believed to happen only once every 10,000 years. But the big question was, what exactly caused it? That mystery gripped astronomers for months and wasn't fully addressed until April of the following year. From the beginning, it was clear this was a long-duration gamma-ray burst, typically the result of a massive star undergoing a supernova. However, things didn't quite add up. Key features usually seen in supernovae were absent during the explosion and in the afterglow, turning GRB 221009A into a true cosmic enigma.